Okay, so this video here is the advanced version of the post from yesterday, which is what is IIoT. So we've yesterday I explained, and again I'll reiterate that this video series is designed to break some fairly complex concepts down into plain speak. So we're doing a whiteboard session. We basically shot a little bit more than an hour worth of footage, where we basically posed some questions, common IIoT questions, and we've broken that up, I think, into 6 videos that are getting posted every other day or something like that. So as a function of the comments that came out of the original video, we determined that on the off day, I would just shoot an impromptu, more complex discussion. So that's what this is today. If you want to see the basic video, the plain speak video, you can go to our LinkedIn page. All right, so what is IIoT and for advanced people? Okay, so in order to answer that question, what I want to do is explain what it is that businesses do. What do our customers do? Most engineers should be very familiar, controls engineers and process engineers should be very familiar with this, the business stack. That is level 0, 1, and 2, 3, and 4. 4 is business planning and logistics. This is where everything starts. I sell a product. I schedule a ship date. I manage my business. I handle accounting, cost analysis, all that stuff. And then I create a work order for the widgets that I'm going to sell. Level 3 is manufacturing operations management. We like to call this execution. This is the execution layer. So in the execution layer, this is where we manage things like recipes. This is where our production schedules are stored, reliability, quality, DQIP, all that stuff. Okay. And then levels 2, 1, and 0 are the controls layer. So this is how we actually produce the widgets that that came from our level 4, our business planning. So through the control layer, we produce the widgets, and then we go back up through manufacturing operations, and then we dispatch and get paid. Okay, so it's the process, the business process is level 4 all the way down to level 0, and then all the way back up to level 4. Okay, so this is what our clients are trying to accomplish. Okay, the standard U.S. manufacturers. So what we're going to do is talk about what is IIoT in a very advanced way. Okay, so there's lots of arrows here. I'll explain everything. First thing we're going to do is focus on no IIoT. This is the traditional structure. You'll notice PLC, HMI, SCADA, MES, ERP, and cloud line up with our 4 business layers. Okay, our level 0, 1, 2 are right here. PLC, HMI, SCADA. MES is in the middle. That's level 3, and level 4 is ERP. So you'll notice we have cloud now, which is a new layer, and that cloud is where machine learning comes into place. All right, so let's take a look at the traditional, the non-IIoT structure. So out on the floor, we have our pressure transmitters, our flow transmitters, and our RTDs, all of our field devices. This is the level 0 stuff. This is how we automate our business, and this is how we automate our process. Okay. Those devices are basically connected to PLCs, embedded controllers, CNC controllers over field protocols. So that's 0 to 10 volts DC, 4 to 20 milliamps, and just either 24 volts DC, 12 volts DC, or 120 volts AC. Okay, so that's what the purple is. The purple is the native field device protocol. Okay, the PLC then interacts with the HMI over generally OPC UA or some type of other native protocol. Okay, Our PLC has a tag namespace, and any controls engineer knows that you're building tags inside of ignition, or inside of ignition on the brain. You're building tags inside of your PLC. So this could be Siemens. In this case, it's a Compact Logix, but it could be S7 1200. It could be any type of PLC if you want to use Automation Direct or any of the other stuff that comes off the shelf. It talks to the HMI one of two ways generally. One of three ways. So it could talk to the HMI over Modbus in the old days. Then we went to OPC, and then we went to OPC DA, and then we went to OPC UA, the unified architecture. And generally, this is done poll-based. So the HMI makes a request to the PLC, and the PLC returns an answer to that request. There is also a tag namespace inside of the HMI. The HMI has its own tags that it is using to create the visualization. Okay. The SCADA system, which is really more like, think of a SCADA system as a grouping of HMIs. The HMI in the PLC is generally built by the OEM, the original equipment manufacturer, okay? They generally build this, and this is what they specialize in, okay? So they use the protocols they prefer. They use the hardware that they prefer, specifically whether they've negotiated some type of strategic partnership or good pricing. But this is generally done by the OEM. The SCADA is almost always done by the plant or the integrator. The SCADA system is really a combination of all the HMIs, but it's really done inside of a unified interface, a unified user experience. This is where alarm management, all that stuff happens. So the SCADA system is going to get its information from the PLC, generally over OPC UA or Modbus. It's going to poll the PLC. The PLC is going to respond. It could also get information from the HMI. I mean, everyone knows that a lot of HMIs serve as OPC UA servers. So the SCADA system can get the tags from the PLC, or they can get the tags from the HMI. A much more common architecture is we add in an off-the-shelf OPC UA server. And why do we do that? Well, because very rarely, for whatever reason, very rarely does this hardware, do you find two different manufacturers whose hardware speaks the same language. If it's not Modbus, that is, if I'm not using a series of PLCs that all speak Modbus, then I have to have some type of unifying communication structure. Kepware does that, right? What is Kepware known for? They basically write drivers for all of this different hardware. So they have a Allen Bradley driver, they have a Siemens driver, they have three or four or 500 different drivers. They talk MT Connect off CNC machines. They talk everything, right? So then what Kepware's place in the business is they sell an OPC server, okay, which means that Kep server talks to the devices in the field, the PLCs, over its native protocol. So we have hundreds of them plugging in here. And then Kep server talks to the software over OPC UA. The HMI would be an OPC client. The SCADA system would be an OPC client, and the MES system could be an OPC client. That's why we see these connections. But essentially, everywhere where you see a red arrow, that's that's a traditional controls protocol, OPC UA, Modbus, SIP, you name it, right? So that's what we have here. So you see, there's lots of everywhere that you see an arrow, there is engineering involved. Okay, so we have to an engineer has to physically make this connection. You know, they have to wire the device in. They have to wire the device in, and then they have to add the device into this namespace. Same thing here. The HMI, they've got to bring these tags in and then add those tags into the namespace. Same thing here. They got to bring the tags in. Now, Kepware is a little different because you can do what's known as an explicit OPC UA read. That means I could have a client out here, an OPC client, that sends a command to Kepware, gets down to the device level in the name tree, okay? And it says, go to that device and ask for the register that is at MW1, okay? So that's memory word 1 inside of a Siemens PLC. I wouldn't need to have a specific tag inside of Kepware to do that. So I could do an explicit read. But in most cases, people are building tags inside of Kepware. There's also excuse me, Software Toolbox and Matricon, and there's lots of different manufacturers of OPC servers. So, but you also have a namespace in the OPC server. Then our SCADA system oftentimes connects to the OPC server, to the PLCs, to the HMIs, and to other stuff, namely databases, gets information from databases. And you have to create a namespace inside of the SCADA system. The namespace is used for your windows to reference tags and show values on the screen. The MES system, if it is connected, that is, if it's connected to the OT, that's your operational technology. If MES is connected, it is likely connected to the SCADA system over OPC UA. It may be connected to the OPC server over OPC UA, but that is very rare. So I'm going to go ahead and delete that one. Most of the time, the MES system is getting its information from the SCADA system, if it is getting information automatically. But more times than not, the MES system is transmitting its information down, getting information from the floor through people. So what would happen in this case is human beings are monitoring the SCADA system, building out a shift report, and then updating a report in the MES system, and then updating a report inside the ERP system. The ERP system, which is our level 4 down here, the ERP system, more times than not, is not connected to the MES system. It's connected through people. But if it is, it's generally connected through like a database connection or a software API. But again, remember, everywhere here, ignore the yellow arrows because those are people. Everywhere you see an arrow on this side, on the no IIoT side, is money. That is a place where you've got to pay for engineering. And every time you add a new PLC in the field or add a new instrument, you got to pay for engineering at all those layers. So if I add a new device in my field, let's say I just add a new pressure transmitter, I have to wire it into the PLC. Then I have to add its tag in the PLC. I've got to add its tag in the HMI. I've got to add its tag in the OPC server. I got to add its tag in the SCADA system, and then build and then add it to my visualization. And then I've got to do the same thing in MES, all the way up. Every time you add a device, every time you add a new piece of equipment, that's the way it works using no IIoT. All of these arrows are the reasons why manufacturers are not innovating, because they get sticker shock when they see this money. This is also the reason we have lots and lots and lots of really, really small integrators. 95% of all systems integrators, engineering firms, controls engineering firms in the world do less than $2 million a year in revenue and have 5 or fewer employees. 95%. Why? Because integrators generally specialize at one of these layers. The standard integrator is either a process automation integrator, a SCADA integrator, MES integrator. They're generally not all three, and they definitely don't know how to do ERP. I've worked for, prior to going into business for myself and creating my own company, I worked for 2 of the leading integrators in the world. And on the ERP side, we call this business intelligence. One of them didn't have a BI person, and the other integrator had one, and that person never worked on business intelligence. He was always doing this kind of stuff. Okay, so I mean, this is designed to look messy. This is the way it is. If anybody who does this job knows that this is a mess, and this also means our customers are not innovating, and we're basically doing the same thing over and over and over again. All right, so now I'm going to go over to the IIoT side. Okay, so I'm going to start with how do we use IIoT with legacy devices, right? So our customers are not going to get rid of the PLCs they have. They're not going to get rid of the instrumentation they have. So the answer is to start building an IIoT infrastructure with legacy hardware, you're going to need some type of gateway. Alexis makes the ReadyGate 400. It's a very popular IIoT gateway. There's lots of other ones out there. I personally prefer the Maple Systems CMT SVR. So I generally put the Maple Systems CMT SVR in here. It's about $300. This is more expensive. The ReadyGates are. But the ReadyGates talk more serial protocols and that kind of stuff. But Maple Systems, in my opinion, makes the best gateway in the middle. What I would say is the second best option out there is to use Ignition Edge. So Inductive Automation has a product called Ignition Edge, which has all of the IIoT protocols. So essentially what you do is you would put Ignition Edge, and I don't want to use this icon because Ignition Edge green, but you would put Ignition Edge here running on a piece of hardware. It would talk to the PLC over its native protocol using a Rockwell driver, because Ignition Edge has all the Modbus drivers, Siemens drivers, all that stuff. You would talk to the legacy equipment through its native driver, and then Ignition Edge converts it into MQTT and allows you to publish it into the namespace. But the ReadyGate does the same thing. So does the Maple Systems HMI, which I thought I had a device here. They are not the only ones. There are other solutions out there. I'm just pointing those two out. All right, so that's how you get your legacy devices plugged into an IIoT infrastructure, okay? And then what about the new stuff? So the new stuff, so now what I'm using here is an EasyRack PLC made by Easy Automation. It's called the EasyLogics. We use a ton of them. I was actually really skeptical because of their price point. I didn't know they'd be quality. They're phenomenal. We love them. We use them in lots and lots of applications. My opinion, they are the best PLC on the market for 90% plus of the applications out there. But we're going to use an IIoT PLC. Now we refer to everything as edge devices. Okay, so a VFD is an edge device. A Coriolis meter is an edge device. A flow transmitter is a edge device. These are the BMB SmartWorks devices. That's an edge device. These are smart transmitters. You basically have no physical connection between the sensor and the PLC. It's all done over Wi-Fi, but they all speak MQTT. So what happens is these devices talk back to your PLC for process control over the native protocol. All the process control is done over the native protocol. So whether that's Modbus, whether that's 4 to 20, whether that's 0 to 10, whether that's 24 volt DC discrete, whatever, all of that that's all done over the native protocol. Then what happens is the PLC then publishes all of its tags into the namespace. Each of these devices out here, though, because they're IIoT devices, they also publish their tags into the MQTT namespace. The ReadyGate publishes the tags of all of the devices it talks to, or Ignition Edge, plus it publishes tags about its health into the namespace. Our HMI can talk directly to the PLC over its native protocol, and it can publish information to the namespace. The SCADA system publishes into the namespace. The MES system publishes into the namespace. The ERP system publishes into the namespace. Machine learning publishes into the namespace. Everything that we're looking at here, this is MQTT. Everything that's green is the MQTT protocol. So now what happens is, not only do we have our process control namespace, which is my business, my plant, my area, my line, and my cell. We would have process values at underneath line and underneath cell. We would also have information from the machine learning stack being published into the namespace. So machine learning may be consuming information from this namespace, running an algorithm, and then publishing additional tags underneath this cell, which may contain next predicted downtime event, next predicted failure, etc. Same thing with the ERP system. The ERP system will consume information from the namespace, handle all of its costing, for example. What ERP is really known for is costing. You could do costing analysis, and then ERP would publish information about the real-time cost of this cell or this line or this area within a plant or this plant itself in real time. All consumers, all the applications that users are using, they are getting their information from the same place. So everything that's in the ecosystem is a consumer and a producer of information, right? So one of the things that you notice here is that there's no engineering involved in these green arrows. When I install my machine, so everything inside of this green is made by the OEM, The OEM just points this its machine to the namespace. And what we do is we tell it, hey, your area, your enterprise plant and area path is this, and your line's ID is going to be line 41. And so when they point it in, that machine just shows up, line 41, with all the tags from the OEM. Then the MES system immediately can subscribe to that information. The ERP system can immediately subscribe to that information. Machine learning can immediately subscribe to that information. SCADA can immediately subscribe to that information. All right? So that is the advanced look of IIoT. That's this. Now, I mean, you don't have to be a rocket scientist to see the value of this transformation, right? Going from the pre-internet days, this mess here, to a digitally transformed enterprise. Okay? The biggest complaint that I have about the really smart people who have developed this technology and are advocating for it is they never talk about it in terms where the average person can understand it. I don't understand why we have to talk so in such high terms. And that's the reason that we have this video series. The idea here is to help explain to non-technical people the advantages of IIoT. Okay? And so that's what we have here in an advanced look. That's the deep down, this is supposed to be the meaningful look of IIoT. And one of the things I just want to point out, so on this side we have our cloud, our ERP, our MES, our SCADA, and our PLC HMI layer. And we call this edge over here. That's what we've got here. So if anybody's got any questions, please don't be afraid to send me a message. I've received, scores, 40, 60 private messages asking for more information about IIoT and the MQTT protocol. Happy to answer the questions. I am a busy guy. I do have a lot of projects and a lot of companies to run, but I will take the time to answer every question. So if I haven't answered your question thus far, rest assured I'm going to get to it. All right, thanks for watching, and look out for the next video, which I believe is What is the Digital Factory? That video, it's already been cut, and I believe that's the one that's going to be released next. We're going to explain what is the digital factory in that whiteboard session. So thanks for watching, and good luck. Bye.